talk about how the electrons fill into these energy levels and sub-energy levels. The sub-energy levels, again, are the particular types of orbitals. One of the things we need to know, and you need to memorize it, and this will become obvious as we do it. This is called the S block, this set of elements, which includes helium. In many ways, helium used to be represented right here, but now they put it over with the noble gases. This section here is going to be called the P block. This section will be called the D block. And the F block will be right here. So you might want to label those on your periodic table. I'm going to have to erase mine so we can do this. So I'm going to erase. Oh, one other thing. These numbers on the right, which I'll keep putting them up, are the principal energy levels. And I'll explain as we go. You have to have that organization in your head before we get started. So let me clear the drawings. Okay, let's start with something very simple. We'll take hydrogen. How do the electrons go in there? So hydrogen has one electron for hydrogen. And so it goes into the first energy level, which we represent as a 1. And then it's filling this block here, which is an S block. So it's 1s with a 1. I always have trouble with this. The S is lowercase. All the orbitals are lowercase letters. Alright, so that's the electron configuration, which is quite simple for that, since we only have one electron. And the orbital diagram is represented as a dash, which represents the orbital, and it's a 1s, so we label it, and we put an electron in. Now notice I draw an electron as a half arrow. That's because electrons can have counterclockwise spin or clockwise spin. They sometimes call it spin up or spin down. The electron can spin this way or it can spin that way. And we represent those with one arrow up, one arrow, half arrow down. You'll see how that works in a second. Let's do another one. This is the orbital energy diagram. This is the electron configuration. This will become obvious as we do these. Let me erase. Helium, 2 electrons in there. Helium has 2 electrons. Remember, we can put 2 electrons in any orbital, so the first energy level is what we're filling. That's what that 1 represents. Right there. So it goes in the 1, and it's the S block. Remember, helium is an S block element. It actually belongs right here, but we've chosen for various reasons to put it over here. So it's a 1s, and there's 2 electrons in there. So the orbital energy diagram would be a 1s, and we have one half arrow up representing spin up and spin down, or spin clockwise and counterclockwise. Doesn't matter, just so they're opposite spins. And this is our orbital energy diagram. This is our electron configuration. Pretty easy so far. Let's do another element, say beryllium. Let me erase. So we're going to do beryllium, which has 4 electrons. So I start here with the hydrogen at the top, and I go through here. That's 1 electron, 2 electrons. So that's the 1s orbital. We're on the first row. That's how I know it's a 1 with 2 electrons. Then we come down to the second row. Right here, we put an electron in here and here. So that's 2. For the principal energy level is 2. I know it because I'm in the second row. And it's an s orbital. I know that because I'm in the s block here. And we put 2 electrons in. That's 4 electrons. We're good to go. We're done. So beryllium has an electron orbital energy diagram like this: 1s, 1 electron, 2, and 2s like this. So notice I put the 1s and the 2s underneath this time. You can do it either way. You'll also see them this way, like this. And in this case, the energy is increasing up, and here it's increasing in this direction. I prefer this method. But if you see something like this somewhere, don't panic. It's just they've moved the axis. Let's do something a little more complicated. Oxygen. Oxygen has 8 electrons. We get that from the atomic number, 8 electrons. And we'll start putting them in. We start at this row. Always we start up here with the 1s, 2. Then we start filling the second row right here. So that's the 2s. I know it's 2 because it's on the second row and it's in the S block. You have to memorize that this is S block here, P block, D block, and F block that I clearly drew out earlier. Then I start filling p orbitals right here, and I fill 1, 2, 3, 4 electrons. So it is the second row, so it's a 2. It's the p block, so it's a p, and I put 4 electrons in there. Notice how many orbitals are in the p orbitals. We always had 3. Hence, I can put 1, 2, 3, 4, 5, 6 electrons in there, representing 6 elements. This case, I only put 4. So this is oxygen. This is the electron configuration. And here is the orbital diagram. 1s with 2 electrons, 2s with 2 electrons, and the 2p with 4 electrons. Now remember, there's 3 of these orbitals, and I can put 2 electrons in each one. And one of the rules that we haven't specified yet is electrons have to go in orbitals of the same energy, which are these p orbitals, singly before they go in doubly. What that means is I put 1 in, then I go to the next orbital and put an electron in, and go to the third orbital and put an electron in that way. Now I start refilling them. I put the 4th electron in there. So that is the correct electron configuration. Always fill orbitals that are the same energy level singly before you do it doubly. Sometimes, and you might see this, these orbitals are called degenerate. I don't ask this in any questions, but these are degenerate orbitals because they have the same energy level. All right, let's go and do another one. So we just did oxygen. Let's do sulfur right underneath it. You'll start to notice some things about this. When I go into sulfur, I have 16 electrons. Okay, so we start again. 1s, and there's 2 electrons. Then we go to the second level, and we're going across these 2 elements. That's 2s, 2. Then we put some more electrons in. 1, 2, 3, 4, 5, 6. That's the p block. 2p, it's the second row, so it's a 2. Second energy level, and it's a sub-energy level p. Then the 3s, third energy level, 3s. That's because we're in the third row. And the 3p, 1, 2, 3, 4. 3p, 4. There's our total electron configuration. Then we would just start here and put 1s, 2 electrons, 2s with 2 electrons, 2p with 6 electrons. I fill them singly, then doubly. Always do that. You'll never make a mistake if you do it that method. 3s with 2 electrons, and the 3p with how many? Let's look. 1, 2, 3, 4. 4 electrons. 1, 2, 3, 4. Looking very similar to oxygen, except we're at a higher energy level. If you go back and look at the oxygen, it was 2s, 2, and 2p, 4. So let's do something like selenium. Selenium is right here, and we have 34 electrons in it. And you might start to think, wow, this is going to be hard to do. There's a lot of electrons. It's going to be easy to make a mistake. Don't panic. Just follow the periodic table. So as we go across here, we got 1, 2 electrons. And we know that's the 1s, and there's 2 electrons. Then we go to the 2s, 2, 2p, 1, 2, 3, 4, 5, 6. Once again, I know it's the second energy level because I'm on the second row going across here, and I just count 1, 2, 3, 4, 5, 6 because I know this is the P block here. Then 3s right here and here, 3s, 2, 3p, 1, 2, 3, 4, 5, 6. Then we go to the 4s, 2. Now here's the problem. The D block are always one off. So even though it's the fourth row, these D blocks are one off, so they're one less than the row, and you just have to memorize that. It's actually the 3D here, the 4D here, the fifth row is the 4D, and 5D here for the sixth row. And if we were doing the F, you would see that the F were 2 energy levels off. So let's go through those. We have, let's see, we're right here at SC, and we're going to add 10 electrons. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I knew it was 10 because it's the 3D, because it's one off. It's one energy level less. You just have to memorize that. 3D, and there's 10 electrons. And I knew I could put 10 in there because there's 5 orbitals, and I could put 2 electrons in each one. And then finally, we're back to the fourth energy level for P, and there's 1, 2, 3, 4 in there. These 4 right here, 4p4. So that's our electron configuration. Now this gets a little bit hard to do, so I'm going to erase some of this, so I have some room. Okay, but we can do it. So we start down here with the 1s, 2s, 2p, fill them singly, then doubly, opposite spins, 3s. Notice I'm just following along here, and or here, however you want to do it, 3s, 3p, 5, 6. Then, if you recall, it was the 4s. Then the 3D, remember the D orbitals are one off, and there's 5 of them. 1, 2, 3, 4, 5. And I put electrons in singly. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Make sure I have an arrow in there. And then finally back to the fourth, 4p, 1, 2, 3, and I have 1, 2, 3, 4 electrons in there. 1, 2, 3, 4. That's it. Notice, for your information, let me erase here. The lanthanides start right here, and the actinides right there. That's it. You'll have to do full electron configurations, and you'll have to do full orbital energy diagrams on the exam.